Okay, today's video is going to cover all of the exponent rules we've learned up until this point. So we're going to use those rules to simplify expressions. Here's all of the rules that we've learned so far, so please pause this video and review this page for the rules that we've learned. Example number 1. It's important to understand that when simplifying expressions using exponent rules, there's no exact process. So what I'm going to try to do is follow the order of operations, or another way of thinking about that is PEMDAS, where I start with the parentheses, then I move on to the exponents, which in this case would be like the power rule, and then after I've done everything in the parentheses and the power rule, I'll focus on the multiplication and division. There is no addition and subtraction for these exponent problems, so I don't really have to worry about those last two parts. Alright, so if I'm going to do order of operations, I'm going to start with the parentheses. So inside the parentheses, we've got everything in this numerator which is being multiplied. So if things are being multiplied, I can go ahead and use the product rule, which allows me to add the exponents to simplify. So we've got u, v, a negative 2, and we can go ahead and add those exponents of the like bases. So negative 2 times u, 2 plus negative 3, v, 3 plus 2, all to the 5th power. Now we've got to simplify just the numbers. So 2 plus negative 3 is negative 1, and 3 plus 2 is 5. Now we can go ahead and drop these parentheses once we deal with this exponent. So the exponent is a 5. We can go ahead and use the power rule to multiply our exponents together. So there's three things that we're going to multiply. We're going to multiply the 5 to this 1 of the negative 2. We're going to multiply it to the negative 1. And we're going to multiply it to the 5. So negative 2 to the 5th power, u to the negative 5th power, and v to the 25th power. I just multiplied the numbers. All over negative v to the negative 2nd power. Now what I'm going to do is I'm going to simplify or evaluate this constant, so negative 2 to the 5th power. I know is going to be some negative value. Negative 32. So this negative 2 to the 5th power is actually just a negative 2. 32, sorry. Now we can go ahead and use the quotient rule. So we've got a negative 32 being divided by a negative 1. And we've got v being divided by v. And 25 is larger than negative 2, so we're going to keep the v and write the subtraction in the numerator. So this equals a positive 32. U to the negative 5th. V is 25. Quotient rule, we subtract the exponents. Minus a negative 2. A double negative is a positive. So we've got v 25 plus 2, so we can rewrite our answer as 32. V to the 27th. The last step here will be to write our bases with positive exponents. So we've got one base that we've got to use. We're going to go ahead and flip it. So we're going to drop it down into the denominator. So our final answer is v, or 32, sorry, v to the 27th power, all over u to the negative 5th power. What am I saying? We just made it a positive. U to the 5th power. Example number 2. Let's go ahead and start with the parentheses. There's nothing that we can simplify in the parentheses, no similar bases to multiply, so we can't add exponents. We can go ahead and move on to the exponent part of PEMDAS, which will be to deal with this exponent right here, we're going to multiply it to all of our exponents. So what we get is a negative 2 to the 6th power, m to the negative 30th power, and n to the 0 power is 1, so we can go ahead and just write it as 1, because 0 times 6 is 1. I should have just gone through and made all of those 0 powers 1s at the beginning, but I didn't. I forgot. That's being multiplied to the rest of this, and that's all being divided. Now let's go ahead and simplify the multiplication. It's easier to simplify multiplication. So what we get when we simplify the multiplication, we've got this constant, which we should actually figure out what value it is. It's going to be some positive number, 64. So we got 64, and we know that that's being multiplied by this negative 2. And we just have the m base to deal with. So we've got 64 times negative 2 is a negative 128. M negative 30 plus 2 times n squared. We don't need to write this times 1. All over negative 2 m to the negative 6th n to the 4th. We can simplify this addition to a negative 28. Now we can go ahead and divide using the quotient rule. We've got negative 28 divided by negative 2. We've got our m's. Negative 6 is larger, so let's keep it in the denominator. And our n's, 4 is larger, so let's write the subtraction in the denominator as well. So we've got negative divided by negative is a positive. 128 divided by 2 is a positive 64. Over negative 6 minus a negative 28, and 4 minus 2. So a negative 6 minus a negative 28, I'm actually going to use the calculator for this, negative 6, sorry, minus a negative 28, too many negatives there, is a positive 22. And 4 minus 2 is 2. That is our final answer. Example number 3. So the first thing I'm going to do is just everything at the 0 power, I'm going to make a 1. So we've got negative u to the 4th, v to the 4th, all to the 0 power. So what I can do is write this all as 1. When I rewrite the expression, it looks like this. 1 times negative 2v to the 6th over 2u to the 2nd. These parentheses around both the numerator and the denominator. So all of this goes to 1 because it's all to the 0 power. Now we can go ahead and simplify any multiplication in the numerator. There's none. We don't need to write this times 1. And there's nothing to simplify in the denominator. We can use the quotient rule, so we can go ahead and divide, but there's no like bases other than the constants. So let's just go ahead and divide the constants. Negative 2 divided by 2 is a negative 1. So we've got negative 1 times v to the 6th over u squared. And we don't need to write the 1, so we've just got negative v to the 6th times 5. But I'll leave the 1 there anyways. Let's go ahead and use the power rule to eliminate the parentheses. We're going to take this and multiply it to this 1. We're going to multiply it to the 6th, and we're going to multiply it to the 2. What we get when we do that is negative 1 to the 5th power times v to the 30th power over u to the 10th power. Last little part is to take negative 1 to the 5th power, negative base to an odd exponent. We know it's going to be a negative number, and negative 1 times itself 5 times is just 1, so we know it's just negative 1. Don't need to write the 1, so our final answer can be written as negative v to the 30th divided by u to the 10th. Okay, last example today, and it is definitely the one that has tons of stuff to simplify. Inside parentheses, no multiplication of like bases in the numerator. However, in the denominator, we've got a smaller set of parentheses. Nothing inside the parentheses. We can go ahead and deal with the exponent. Using the power rule, we can multiply our exponents together. All of this can be rewritten as x to the negative 6th, y to the negative 5th, and in the denominator we now have negative 2 to the negative 5th, x to the negative 15th, and the rest of this stays the same. Now when I simplify this, I need to convert it into the numerator because I've got to take it to the positive exponent. So I'm going to convert this to a positive exponent by taking it out of the denominator and putting it into the numerator. So it's going to come up here and it's going to look like negative 2 to the positive 5th power times x to the negative 6. So we can erase it now from the denominator. And then I can actually figure out what negative 2 to the positive 5th power is. It's a negative 32, so I can go ahead and write it as a negative 32 in front. Now I can go ahead and simplify the multiplication of like bases in my denominator. So we can add up the x's and the y's. And then we can multiply the constants. So we've got a negative times a negative now is a positive. So we can write our numerator as negative 32, x to the negative 6th, y to the negative 5th. And then when we add up the exponents for the x, we've got negative 15 plus 5 plus 3. And that's a negative 7. So we can write this as x to the negative 7th. And then for y, we've got 3 plus negative 2, which is just a positive 1. So we can just write it as y. This is now simplified. Now what we have are quotient rule, so we can go ahead and divide. We can divide our x's and our y's. Negative 6 is larger than negative 7, so we'll keep the x in the numerator. And 1 is larger than 5, so we'll keep the y in the denominator. Simplified, we can write it as negative 32. And now we've got negative 7 minus negative 6. So we got that double negative, which is a negative 1. Oh wait, I wrote it wrong. Negative 6 minus negative 7. Sorry. Negative 6 minus negative 7 is a positive 1. So we've got x, that's positive in the numerator, and then in the denominator we have 1 minus negative 5. 1 minus negative 5 is a positive 6. So we've got y in a positive 6 in the denominator. This is all being taken to the negative first power. So I can distribute this, or we can multiply our exponents to 1 times 1 times 6. So essentially what we have here is negative 32 to the negative first power, x to the negative first power, over y to the negative 6th power. Now we can convert these to positives by moving this down, by moving this down, and by moving this up. So we've got y to the 6th power over negative 32 x to the first power. Lots of work, very simple if you stay organized as you go through the problems. Good luck.